All right, so let's break this down. Here's our first problem right here, and it's very closely linked to the warm-up, so that's kind of why I want to do it. But if I don't remember to show you this, I'm going to totally forget, because this seems like it's really complicated, and you might be thinking, hey, the one that we did originally, there was some kind of a symmetry between the f of x plus h and the f of x. Well, this one it's not. Okay. Before I can replace that 1/2 with an x, or this one you can't just do that. So you need to notice this pattern. Now, to me, I think this is kind of like, I don't know, this is just kind of a trick. It's a trick way of doing it, but it does show up on the AP test, so I kind of want to show you. Somehow you have to relate this part right here, which is the x, to this right here. Okay? And a lot of times, it's basically the same thing as if you just put a 0 in for h. So 16 to the 1/4 is actually equal to 2. So one way of tackling a problem like this is to rewrite it. That's what I'm going to do really quick. Only I'm going to make it so you can actually see how this 2 is related to a 16. Okay? Make sure you write this down. Okay? So I'm going to rewrite it, instead of 2, I'm going to write it as 16 to the 1/4 power, because the 4th root of 16 is 2. So now if you notice, it looks more like that problem that we did for the warm-up with the 1/2. You can see the 16 and you can see the 16. So you can think of it as that's really just an x in there, x plus h to the 1/4 power. Oh my gosh, that's embarrassing. Sorry about that. So used to writing 1/2, I guess. Okay, so there's the 1/4 there. Okay. Now from here, what this basically means is you can take the x's, you can take the 16 and replace it with x. So what I'm going to do is rewrite this as, this is really just the derivative of, again, replace the 16 with an x. It's x to the 1/4 power. And then there's a line that goes down here, and then you're just plugging in x is equal to 16. So what this orange step means, essentially, if you were translating this from math to English, that means take the derivative of x to the 1/4 and then plug in x equals 16. Okay. Math people don't want to write all those words down that I just said, so they just use a different kind of notation, a different kind of language. If you've ever heard math is a language, it's like the universal language, that's what they say. You just have to be able to translate it in your brain for it to make sense. Okay, so let's do this step. We're going to do the derivative of x to the 1/4, and then we're going to plug in 16. So let's do that. What is the derivative of x to the 1/4? Does anybody want to help me out here? Thank you. 1/4 x to the negative, whoa, that's embarrassing, to the negative 3/4. Okay? Because 1/4 minus 1, remember you have the minus 1 from the power, is going to be a negative 3/4. Okay? All right, and then we are going to plug in, well, I should have, oh, whatever, it doesn't matter. I should have plugged in 16 right away in there, because now I end up just rewriting this again, but that's okay. So this is going to be 1/4 times 16 to the negative 3/4 power. Okay. I'm going to do the 1/4 first. So 16 to the 1/4 power is 2. So I'm just going to rewrite this. This is just a little algebra review here. Times 2 to the negative 3rd. Well, that's 1/8. So 1/8 times 1/4 is 1/32. And that's your final answer for that one. Now, just to practice doing this on your calculator, what I want to do is do this on your calculator. So what we're going to do is take out your calculator. We're going to do that math 8 thing like we did last time. So we're going to hit math 8 with respect to x, and we're going to go x to the 1/4 power. And we're plugging in 16. Hit enter on that, you get something crazy. Math bracket up, 1/32. Math 8 is your friend in this class, for sure. Does anybody need help with that? Everyone's good with this one? Okay, the main purpose of showing you this problem was just that sometimes they try to trick you with putting a 2 in there, and you're like, wait, what do I do? This is crazy. Usually if you just put this as 0, then you can just think 16 to the 1/4 power is 2, replace it with that, excuse me, it becomes more of a problem that you should be more accustomed to. Okay, let's do the next one. So this one, it says the derivative, remember this symbol here means, bro, take the derivative of this. Okay, that's a rough translation. So you're doing the derivative of 3x to the 4th, which is what? We're all friends, just yell it out. 12x to the 3rd, thank you. Minus, what's the derivative of 6x squared? 12x. Now, what's the derivative of 13? 0. Okay, that is the final answer. Not much work to show on that one. Okay. Well, if you wanted, you could use limits on that, but why? It would take you a year. Okay. One thing that's super important to understand too is derivatives, this d over dx, it distributes to each one of these things. Okay. So if you wanted, you could rewrite it as the derivative of this minus the derivative of that plus the derivative of that. I wouldn't. What's the point? But it is important to understand that because sometimes there's other problems where you have to use that concept that the d over dx distributes. We're eventually going to go over integrals with the antiderivative. The antiderivative also distributes, which is awesome. Questions on this one? Okay. Oh, awesome question. Thank you for asking that. This equation or this expression that you just found, sorry, I know I'm getting all crazy. This expression that you just found, you can put any x in there, any x you want. You just, whatever you want to think of in your brain, this is continuous. You can put any number, any x number in for x, and it will tell you the slope of any of those points of the original equation. That is an equation that tells you the slope of anything, any x you want. Does that make sense? That's crazy. That's what that is, though. So your x could be 1, 2, 3, it doesn't matter. It's a general derivative. It's not an exact derivative at a point. So sometimes that happens where it doesn't actually tell you what x is, but that's what that represents. So that's kind of how I want you to like frame your brain on that. Is like, cool, I just found a little expression that I can plug anything in for x, and it tells me the slope at that point. Okay, sorry, I just think that's cool. Good question, by the way. I should have said that. All right. Those aren't divided by symbols, obviously, because there's an equal sign there. I just was trying to separate them. There is not much work to show on these because it's just doing the formulas, but I still think it's good to practice it. So this one, we're doing the derivative. Did that make sense how I answered that? Okay, sorry. All right, so we're doing 3 times cosine of x, but it's asking, doesn't really ask it, so I'm going to write it right here. What is f prime for all of these? Okay, so this first one, f prime, remember f prime is the derivative, is going to be equal to, that's a constant multiple. So if you actually watch the videos, you know constant multiple rule, it just stays there. It's a 3, it stays there. If there was no 3 there, there is still a number there. It's just invisible. It's a 1. So a 1 is not anything more special than a 3, so you just keep the 3 there. I'm just going to bring it over here. Then you need to multiply this by the derivative of cosine x, which is what? Thank you. So it's going to be negative sine x here. Usually people simplify this. You'll see this on my answer keys to be negative 3 sine x. And that's the answer. Okay, again, we're just practicing those formulas. Yes, you will get ones that easy, believe it or not. Okay, the next one here. Why did I put an equal sign? Don't ever do that, by the way. People do that all the time. They'll say this is equal to 2 cosine x. It's not. The derivative's equal to 2 cosine x. You would get that marked wrong because the math is technically incorrect. Really, you want to say f prime of x is equal to 2 times the derivative of sine. The derivative of sine is cosine. So that's the answer for that one. Now, I do want to show you something that's crazy, and I don't think it was in the video, but I haven't watched my own videos in a while. But check this out. So say we had sine x here. Let's blow this up. Do this. So you can see this. Okay. Now, if you notice what this graph is doing here, what is the derivative at this top part right here? At pi over 2, what's the derivative? Just look at the graph. Don't try to calculate the derivative. What is the slope there? 0. Okay. Believe it or not, that's 0, because if you drew a tangent line there, 0. The slope of that line is 0. If you notice, it's grazing it at that spot. Okay. Any hill or valley, the derivative is going to be 0. Okay. Unless it's like a sharp turn, obviously. So that's like a jagged mountain, I guess. Let's just say this is a hill because it rounds off. None of these are math terms, by the way, but you'll notice that it's 0. Now, that means its derivative at that point should be equal to 0. Okay. So if I graph the derivative of this, underneath that, right here, it technically should be 0. Well, the derivative of sine is cosine. What's the cosine of pi over 2? Come on, unit circle people. 0. Huh, that is crazy. Watch this. If I do f prime of x and it graphs it out, it matches exactly with cosine of x. Hey, look, I can do this. It matches with it perfectly if I change the color. Okay, but check this out. Underneath this point right here, the derivative is 0. So you have the original in red, and that purple, it's saying the rate of change at that point in the graph. And it does it for all of them. Look, wherever there's a red, and it's a valley or a hill, like right here, the derivative is 0. Okay, also right here, at this point right here, the derivative is positive. You can make a positive tangent line on that, right? You can graze it at that point. And if you notice, the derivative is positive. Okay, now what about over here? Here, clearly, or even just go here. We don't need to go on the x-axis here. But right here, there's a negative slope there. I don't know what it is, but it's a negative slope. We can calculate it. Now watch this. The derivative is negative. That's insane. Does everyone see that? You're seeing the graph and the rate of change of that same graph on the same graph, the same coordinate plane. That's insane. I don't know. I just think that's so cool. Now, it does not work backwards. If you look at cosine, you can't go, oh, the cosine right here, this slope is 0. It doesn't necessarily, actually, it's going to match for that. It's just going to be negative. It's going to be flip sine. Never mind what I just said. That's embarrassing. Let's go with, if you do the derivative right here of cosine, at this point, it's negative. You can see it would be a negative tangent line. If I zoom in, the local linearization is a negative line, right? Now, if you go to the cosine of it, it's positive. But that's because the derivative of cosine, or the derivative of cosine is negative sine. So it works one way, but not the other. The other way, you have to make it negative. Okay, I'm getting a little ahead of myself. If you don't understand what I just showed, it doesn't really matter. We're going to go over it in more detail later. The main thing that I want you to focus on right here is doing the formulas. So sorry, I just got a little off track there. Okay, any questions on how I got 2 cosine x? All right, the next one, people at home too, just chime in. I better check just in case I didn't hear. All right, the next one, we're doing f prime of x here. It's going to be equal to -7 times the derivative of cosine. I'm sorry, the derivative of sine, which is cosine x. That's that one. Okay, other formulas that we have to use since this is exponential. We're going to do f prime of x. Now, the easiest way that I always think of it is exponential is itself times some other factor, which is just ln of whatever it is. And if you watch my video, you actually see where ln comes from, which is absolutely insane. If you saw that. If you didn't, then that's fine. It doesn't really matter. You don't need to know where ln comes from, but I just think it's kind of cool that ln is defined using limits. I don't know. That's not how it's taught because we can't teach it until calc to understand what limits are, but that's the answer for that one. All right, this one, it's just going to be the -2 constant multiple stays. So I'm just going to rewrite it there. And what is the derivative of e to the x? E to the x. Okay, think about that for a second. The derivative of some parent function, e to the x, is itself. That's insane. And that's part of the reason why e is such a big deal. We're going to go over that a little bit later, and you'll go to it in a huge deep dive in Calc 2 as well. But that's it kind of shows how special E is. Now, if you wanted to, you could treat it like an exponential function. So you can do -2 e to the x times ln e. If you notice the way what I just did over here, it kind of matches. Only instead of a 2, it's an e. But what's ln of e? 1. Okay, so ln of e is 1, so why even put it in there? But yeah, it's just getting crazy. Okay, then we have log base 2 of x. Oops, let's do orange. So the derivative of this, again, following the formula, it's going to be 1 over x times ln of a. In this case, a is equal to 2. So it would just be that. Okay, let's go green here. This one, h prime of x, is going to be equal to, whoa, this is crazy. So you can use chain rule on this one, but it's actually easier to take this 2 and put it in front. So use power rule for logs. So then you're going to end up with -8 log base 3 of x. So now the answer is just going to be -8 over x ln 3. Okay. Again, I'm just following the formulas that are given that you study. They should already be in your notes. Unless if you didn't take notes in the video, that's fine too. Just following the formulas. And then what is the derivative of ln x for this last one here? Just yell it out. Derivative of ln x is what? Nobody remembers? Keeps it home. All right, it's just 1 over x. So you have 5 times 1 over x, which is just equal to 5 over x. Kind of weird how you take the derivative of a transcendental function and you get a algebraic function out of it. Crazy, crazy. Okay. Again, what you just found was an equation. If you plug any x in, it tells you the rate of change at that point. Okay. That's everything we just found. We found equations that plug in any x tells you the derivative at that point. All right, let's do a product rule practice problem. Here is how I would set these problems up. You do not have to set it up this way because some of you can just do it all in your head. Absolutely, that's how you should do it. That's actually the first thing you should do every time you see a problem like this, is try to do it in your head. We've talked about this before. Try to solve it in your head right away, which is basically kind of what we were doing over here because there wasn't a lot of work to show. I just think it's like, okay, f prime g, so it's going to be cosine times the quantity x squared minus 1 plus 2x times sine. I just did it all in my head. Now, if you wanted, you should, at first at least, if you can't do it in your head, then break it down. So this is what I'm going to do here. I'm going to say f and f prime, and I highly recommend doing it this way, g and g prime. If you can't do it in your head, do it this way. Okay. Now, the reason I'm finding those 4 things is because that's what product rule needs. I need an f, I need an f prime, I need a g, I need a g prime. If you don't remember the formula, it's right here. The top one. F prime g plus g prime f. Okay. You'll notice I always start with f prime g too, because then if you always start with that with product rule, you're more likely to start with it with quotient rule, which is f prime g, g prime f, or gf prime. Those are the same thing. It's just different order, but multiplication doesn't matter with the order. No. Okay, so this right here is equal to this right here. So it's just kind of a good habit to get into. Doesn't really matter, but that's why we need to find these things. Let's break this down. Your f is going to be this thing here. Okay, I'm going to put a box around that. Your g is going to be right here. Okay, so that's my f and that's my g. I can put a sign here. and then I could put an x squared minus 1 here. Now I can do my derivative. What's the derivative of sine x? Thank you. What's the derivative of x squared minus 1? 2x. Okay, and if you set it up this way, f prime g is going to be cosine x times x squared minus 1 plus f g prime, which is going to be 2x times sine x. And this is the final answer. Do not distribute. Okay, there's no point in it. It does not make the problem look any easier or, you know, anything like that. But for some people would want to distribute this cosine here. Whoops, this cosine here to each of these. Do not do that. There's no point. AP usually doesn't do it on the multiple choice. Oops. Okay. Questions on this? If you think this is easy, you are awesome because that's literally an AP problem. Okay, I didn't give you an easier one first and then, you know, working up to an AP. This is literally an AP problem. The hardest thing on this probably right now is just memorizing all of it. Memorizing the formula. Now, if you notice, this was product rule, but I also had to use a trig rule here to find this derivative, and then I'd use power rule here to find this one, and constant rule as well. So tons of rules in these, so you do kind of have to see that. One way of seeing it is just looking at the original equation and thinking, what is the broad rule that I need for this? And when I see it, I go, oh, there's a function times another function. Light bulb goes off in my head. You need product rule. Okay, it's a function times another function. Questions on that? Nothing? Peeps at home? Okay. Now we got quotient rule. Ooh. Okay, quotient rule is going to be set up the same way. We're going to do an f and an f prime. F is always on top. Make sure you don't mess that up because order does matter for this. And then g and g prime, g is on the bottom. So we have x cubed minus 3x, x cubed minus 2. Probably could have just done long division on this, but it doesn't matter. We're trying to practice this. That's a 2. Always assume you're wrong, so check and double check. Okay, so this is going to be equal to girlfriend prime minus friend girl prime and then we're dividing all of this by g squared. See if anything cancels. Looks like no. Now you could simplify at the top if you distributed, but again, you don't really have to do that all the time. The only time you really have to, like they're forcing you to do it, is if this was on a multiple choice and they did it on a multiple choice that way, where they expanded it all out. But we're just going to keep it there. Again, if it's free response, leave it like that. Don't try to distribute everything and cancel stuff, and it's just a headache. Make sure you remember the minus. Questions on quotient rule. Oh, geez. Questions on quotient rule. Okay, this part right here that I'm highlighting, again, you don't need to do it that way. But if you want to like keep things organized, then do it. Okay, but some of you are just going to go straight to the green, filling it out. The green stuff that I have up there, and that's fine. I would not fill out the f and f prime, g and g prime. I'm doing it because I'm trying to like teach you, and everyone's got different, you know, degrees of comfortability for that. But if I wouldn't do it, I'm not going to expect you to do it. All right, here we go with this one. Now, the thing I want you to see on this is that it's a function, x minus 1, inside of another function, the squared function. This is a composite function. And this is where I'm going to kind of teach you onion rule. Okay. By the way, onion rule is not a thing. So if you Google it, it's not going to show up unless someone else came up with onion rule as well. But this is how I would do chain rule. It makes it way easier than using the formula. So I would kind of throw the formula out of your head for now and just focus on what I'm going over. Okay. So the first thing you should notice is there's this outside function and then there's an inside function. Okay. The easiest way to tell if something's the inside function is it's in parentheses. Okay. So x minus 1 is the inside function. So what you want to do for this is do the derivative of the outside layer first and do not touch the inside layer at all. So we're going to do the derivative of the squared. Well, it's a power because it's up there as a power. If I gave you something where it was like x squared, you know to bring down the 2. So we're going to bring down the 2 on this. You're going to have 2. Now don't do the derivative yet. You have to rewrite whatever's in the center. And then it's going to be to the first power because you minus 1 from the power. Then the last step is to multiply. So this layer's done. Now the next step is to multiply by the derivative of this. What's the derivative of x minus 1? Well, you're close. 1. It's 1 minus 0, right? So your final answer is going to be this 2x minus 2. Okay. Now you might be thinking, whoops, you might be thinking, well, couldn't I just expand out the original? And then do the derivative of that? Yeah, you could do that. This derivative would be 2x minus 2, which matches it. Cool. If it's squared, you can do that. AP is not going to give you one that's squared, though. Okay? They'll give you something like this. So we're going to do another problem right now. Oops. I'll give you something like this. What is 3x minus 1 to the 7th power? Okay? Expand that out for fun if you want. Don't. It's going to take too long. So let's just say we want to do the derivative of this. Well, using onion rule, chain rule, whatever you want to call it, it takes 2 seconds to do this. Okay? So we're going to bring the 7 down first. That's the outside layer. So it's going to be 7 times 3x minus 1. If you notice, I did not do anything with the 3x minus 1. Don't put a 3 in there. Sometimes people bring the 7 down and then they do the derivative of the 3x minus 1. They put a 3 in there because the derivative of 3x minus 1 is 3. Don't do that. Minus 1 from the power. Then do the derivative of the inside layer, which I already just said was 3. You're done with the problem. There you go. Okay, I mean, I guess if you wanted, you can multiply the 7 and the 3. But again, it doesn't really matter unless it's multiple choice. Dunsky. Don't try to expand that either. It's going to take you a year.